It is my pleasure and privilege to welcome all of you to this half-day virtual conference on data centers. Data centers on sustainable energy efficient design with steel, which brings together key representatives and stakeholders on one single platform. May I take this opportunity to welcome you all and to extend a further word of welcome to everyone present here this morning. To start with, Indian Steel Construction Council started to form a vibrant community of steel enthusiasts to learn, share, and grow by using this knowledge sharing and networking platform for the construction industry by providing the bouquet of services such as technical workshops, steel construction summit, conferences, webinars, and much more. Moving on, India is seeing a sudden rise in creation of data centers. Capacity primarily driven by conventional data center services companies, which are now investing to serve the accelerated hyperscale demand over the next 3 to 5 years. Indian data center market is expected to grow at a compound annual growth rate of 8% over 21 to 26. Drivers would include rapid adoption of cloud-based business and increased proliferation of online shopping due to availability of user-friendly interfaces, high-speed internet, and smart devices. Also initiated by the state governments to attract the construction of data centers in their states for economic growth would shape into massive opportunity. Data center companies across the globe are facing some challenges of designing and operating their facilities to reduce environmental impact without sacrificing performance and reliability. Also, there is an increasing requirement to run data centers as efficiently as possible, with more renewable or green electricity through energy efficient designs and solutions. I believe that steel is right material which would help in encountering these challenges and building data centers that are sustainable with efficient design and solutions. Today, in all probability, marks this occasion the beginning of new chapter of awareness. Over the course of the day, we have the opportunity and indeed the responsibility to dig deep into the pros and cons of how steel could be efficiently used to provide maximum rewards. And as a nation, how far can we reach in creating monuments using steel? I have no doubt in my mind that this virtual conference will be worthwhile experience. And I hope we will take away a better understanding of contemporary usage of steel in data centers. On behalf of entire industry, you are all most welcome to be part of this gathering. I hope you enjoy the rest of this day's program, and I thank you for sharing these special events with all of us. Thank you.
Thank you so much, sir, for setting the perfect tone to follow. Before we begin with the next session, let me take you to what just Mr. Bhole just spoke about is the Indian Steel Construction Council. Indian Steel Construction Council is an initiative taken by MX Business Media and ISCC to form a community of steel experts. There are a bouquet of offerings that it provides, which includes regional series, SCS webinars, virtual conferences like this, complimentary access to our magazine, discounts on a main event, Steel Day, and much more. Some of our initiatives that we have done is our SCS webinars, which we had more than 25,000 plus participants, 35 plus webinars done so far, and 100 plus experts. We have also done SCS workshops through these through ISCC with Mr. Anil Agarwal, with Mr. Dr. VVS Murthy, with Dr. Devin Huber and VV Sood and Mr. Bhavin Shah. Also, to give you another update and an exciting news is we have, just like things had stopped in the lockdown, we have come up with a new initiative wherein the SSMB magazine, Steel Structures and Metal Buildings magazine, is no more just reading, but you can get interactive because there are videos which you can actually view through when you view the magazine copy. To know more about ISCC and to avail the membership, please check the chat box details so that you can avail the membership. Without wasting any more time, let me welcome the keynote address of the day. Sunil Gupta, co-founder and CEO, Yota Infrastructure. Sunil is known as the data center man of India, has built and operated the most third-party data centers in India. His efforts have been instrumental in India's data center growth story and have been recognized in the industry in the form of numerous accolades on domestic and global platforms. He has been featured in the illustrious Data Economy APAC 50 list and is one of the 100 personalities to watch out for in the next decade, who are poised to heavily influence direction and transformation of the global data center and cloud markets. May I please welcome Mr. Gupta.
Mr. Gupta, you're not audible.
It is my privilege to share with you India's data center growth story, a sector which has grown and transformed tremendously in recent years. And I had the opportunity to be a part of this sector almost since its inception, which was late 90s and early 2000s. And I'm lucky to be able to contribute my bit to the evolution of data center industry in India. To give you a perspective of the growth story of data centers in India, just about 5 years back, data center development in the country was limited to small individual buildings. 1 lakh square feet of building with about 1,000 racks in which the equipment lie, with about 6 megawatt of critical power was defined as a large facility. And this possibly shows how small the industry was. Data centers are measured by the amount of power they carry. And you can take broadly 1 lakh square feet of facility to be carrying about 5 megawatt of critical power and 10 megawatt of total power. The total industry till about 2014 was just about 200 megawatt across multiple data centers by all the providers. In the last 5 years, because of multiple growth trends, huge investments have been made and continue to be made in building large data center facilities, which are much, much bigger than what we were making earlier. And this scale is going to be only growing as the country's digitizations continues to take massive strides. Data centers in India are no longer being talked in terms of only buildings now. Today, we all are talking about massive data center parks, which will have multiple data center buildings, which will have the entire ecosystem of a huge amount of power and fiber coming in, and practically assuring the customers who host in these data centers infinite scalability to cater to their existing and future needs. Now, what are the drivers? You and me today are accessing internet all the time, whether to access a WhatsApp, whether to access a YouTube, whether to book a Uber or Ola, whether to purchase something on Amazon or Flipkart. Even in our professional lives, when we access our ERP or email, every moment of time, we are using internet and we are accessing content, and this content is hosted in some data center. So if our lives, both as consumer and as professional, is continuously becoming more and more digital, and data centers are the place where all this digital content is stored, processed, and analyzed all the time, it is very, very safe to assume that as much digitalization grows in our life, as much should be the underlying data center infrastructure in that country. Now, we know that how internet in our lives has, the presence has increased big time. We used to access internet over dial-up modems in early 2000. 2G came in our life, then 3G came in our life, and then 4G came in our lives. And we have all seen how the speeds of downloads have increased. We are all waiting for 5G to come, and that will make the speeds of download to be maybe 10 times or 15 times much higher than what we access today. We all know how we have become so used to accessing smart TVs and OTT content. We know how we have become addicted to WhatsApp and YouTube's and Netflix, in our lives. So with all this growth, and there's one more factor, there's one more factor. The enterprises, for their enterprise applications, they used to put all of them into their own captive data centers in their own headquarter buildings, long back. Today, with the complexity and size of enterprise sector technology growth itself, all those enterprises are just discarding their captive data centers, which are small computer rooms in their buildings. They're actually shifting all that to third-party data centers, which are again the massive data center buildings I was talking about, owned and operated by third parties, like Yota. So because of one side, the consumer internet growth, and on other side, enterprises moving their workloads to data centers, because of both these trends, the data centers are growing in terms of size continuously. Now, what is the size of Indian data center market today? From 200 megawatt in 2014, it has become 400 megawatt already just in the last 5 years, which means capacity has become double in the last 5 years. Now, is it good enough? No. Let me give you one more perspective. India's data center capacity today of 400 megawatt, if we divide it by our 140 crore population, it comes to around 0.28 megawatt per million of population. If I compare that with some of the other developed countries in the world, China is 2.5 times bigger than India in this parameter. Japan, Hong Kong, and Singapore are 7 times bigger than India. Europe is 17 times bigger than India. And US is 39 times bigger than India on this parameter of megawatt data center capacity versus the population of that country. So if we know that in India, we all are extremely digital savvy, we all have smartphones in our hand, we all have the cheapest data plan in the world, we all are using e-commerce and content all the time. there's no reason to believe that India also should not have as much data center capacity, per million of population as some of these developed countries have. And that is where the catch-up game is. In the last 5 years, we have doubled our data center capacity as a country, and all the projections which we are seeing, on a day-to-day basis point out that in the next 7 to 10 years, we will end up creating at least 7 to 10 times more capacity, possibly by 2030. So if we are at 400 megawatt of data center capacity today, it might become 2,500 megawatt or 3,000 megawatt by 2030. And that is a tremendous growth. It means a tremendous uptake of suitable land, a tremendous growth in those construction of the specific building, tremendous growth in everything which goes into construction of those buildings like concrete and steel and everything. Tremendous growth in the MEP services, right? The power generation and distribution systems, the cooling systems, the automation system, the physical security systems, everything which goes into making those data centers. Everything needs to grow big time. Today, the industry is limited to some major cities. Mumbai happens to have around 40% of the total market as of now. Mumbai, Navi Mumbai put together. And Chennai, Delhi, and Bangalore are the second, cities possibly having about 10% or 15% each. And then you have got possibly a Pune and Hyderabad catching up. You may wonder why data centers are only in the main cities. Well, multiple factors contribute to this. Data centers need to be, number one, close to where you have got a huge network density. Because the content is hosted in data centers, the end users should be able to access the content from these data centers with the least amount of latency. So wherever, in whichever city, you have got a lots of fiber connectivity, dense fiber connectivity, data centers will come up there. And dense fiber connectivity with lot of resiliency, redundancy is available today in India only in these major cities. And that is why data centers end up coming in these major cities today. Mumbai and Chennai happen to be the biggest attractive cities at this moment, simply because these two cities are also happening to be the landing point, the international fiber which connects India to the rest of the world, are maximum landing in Mumbai or Chennai. Mumbai connecting India to the rest of the world on the west side, and Chennai connecting India to the rest of the world on the east side. And that is why you see majority of the growth of data centers in Mumbai and Chennai. Second factor for the data center site selection happens to be where your end users are. Now, majority of the end users, the digital savvy end users, happen to be where the maximum cluster of people are there, happen to be again large cities. And again, that is the reason why Mumbai comes up on the top of the mind, Chennai comes up on the top of the mind, and cities like NCR region or Bangalore or Pune or Hyderabad come on the top of the mind. The third factor comes out to be availability of power. Now, power is also available, for example, 24/7 in Mumbai without even a single minute going down. And that also explains why Mumbai remains as a preferred location. But gradually, as we improve our power infrastructure in various cities, as we also get to access green power, we are able to wheel green power into our data center, irrespective of where we make, we will see the emergence of data centers in other cities as well. The data centers which I am talking about right now are very large hyperscale data centers, which each one of which will be around 5 lakh square feet in terms of the constructed space, with about 25 megawatt of critical power, about 5,000 of racks. And these data centers possibly in foreseeable future, because of the factors which I described, may still come up in the main cities on the outskirts of the main cities. But with time, what we see is also, we'll see the emergence of what we call as edge data centers. These data centers will be coming up in tier 2 and tier 3 cities like a Bhopal or like a Indore or a Lucknow or a Coimbatore or a Chandigarh or a Guwahati or a Cuttack or Bhubaneswar. These will be smaller data centers, maybe just about 10,000 square feet of constructed space with just about 500 kilowatt of power and maybe 50 racks. The purpose of these data centers, and they will be coming in hundreds of them actually. And the purpose of these data centers would be that a user in a particular city, his demand for a content on his mobile should not go all the way to Mumbai. His content access should happen right from the nearest small edge data center, which may be in his own city or maybe the nearest city. So the latency which we get today of few milliseconds, even that get reduced to milliseconds. Second is, you might have heard about big strides in IoT, Internet of Things. Today, people like you and me use internet through our devices, but going forward, it is our machines, the devices in our homes, our TVs have become smart, our washing machines have become smart, our home devices have become smart. Factory machines are becoming smart. We are getting robots in our life. It is these things, sensors like connected cars are going to come in our lives very soon. It is these things, these machines will start talking to internet. And when machines start talking to internet, they need to get instructions from some backend, artificial intelligence, driving machine in microsecond, not even in millisecond, for them to do something real time. If that is the case, then these intelligent devices cannot wait for a signal to go all the way to a data center in Mumbai and then coming back to to the machine in taking some milliseconds. So that has to be microsecond. These are the type of case studies which will result into more and more edge data centers coming up in small cities, so that the sensors or the smart devices in those cities can get instructions from the localized data center itself. Let me touch another aspect of the data center industry. We had players in the market so far, 5 or 6 players who were mainly into the data center industry about 5-6 years back. And they were making, as I said, small data center buildings till about 2012-13. Because of this huge growth in data centers demand, not only those players have started making much bigger buildings, foreign investor interest has grown big time. Many of the existing players actually have been bought over by large foreign data center players. And now they have got access to capital and they have plans to make much larger data center buildings. Some foreign players are coming with their greenfield ventures. They are directly purchasing land and they are planning to or are in the process of building their own data center without acquiring or tying up with any local player. There are players like Hiranandani's, which is like myself, Yota, and Adani's, who are the local players who have gone into this business. So you will see with time emergence of multiple, almost all the big global data center players and also some local business houses getting into this business and creating very large data center parks and this entire infrastructure which India needs for the next 7 to 10 years. If I have to sum up what I'm talking about, India needs a massive growth of data center infrastructure, just like our Prime Minister talked about building huge infrastructure for our economy to take us to $5 trillion economy. We talk about railways, we talk about roadways, we talk about airports, we talk about various forms of infrastructure. For our digital economy, which also is supposed to become $1 trillion economy, the underlying infrastructure required is data centers. So as much we depend on digital economy, we need to invest in as much of data center capacity. we will see a massive growth for next 7 to 10 years in this data center capacity. And we'll see, as a result of that, our digital life becoming more and more better, more and more digital will come into our lives, both personal and professional lives. Thank you very much. Thanks for giving me this opportunity to talk to you. Thank you very much.
Thank you so much, Mr. Gupta, for the wonderful keynote address. Before we move on to the next session of the day, would like to take you to an important announcement that we are all set to roll our main our Steel Construction Summit series for the year, and our first stop for the year is Kolkata, which will be held on 16th March in Kolkata, which is it's a hybrid event which will be done both physically and virtually. So to register for the event and to know more about the event, please write to sales@mxbm.in. The same is in the chat box. Also would like to make another important announcement that we would be doing our main grandeur, Steel Day, which would be a 2-day event happening in Mumbai with 2 parallel tracks, 4 panel discussion, and a 2-day event, which is the novelty of the event this year. To know more about the event, do write to sales@mxbm.in, ssmb@mxbm.in, and also the registration link in the chat box. These are the speakers that we had in 2019, and you definitely get to see a lot of projects, a lot of interactive discussions this year as well. Thank you. Moving on to the next session, may I now welcome Mr. Kamlesh Harchandani. Our first speaker of the session, Kamlesh Harchandani, Head Design and Development Projects, Capital Land. Kamlesh has 13 years of experience in data center design and build the same for IT load capacities, and has worked for operation and maintenance of various industries. He specializes in engineering design and consultation for data center. Before I hand over this session to Mr. Harchandani, I would like to thank our main partner, Hempel, for supporting us for the event. Thank you.
Thanks, Carol. Good morning, one and all. First of all, I would like to thank Indian Steel Construction Council to give us this opportunity to talk on data center subject. So I'll just flash the screen with my presentation so that we can begin our discussion. Hope this screen is visible to everyone. Carol, could you confirm, please? Carol?
Visible, sir.
Thank you so much. So again, I would like to thank Indian Steel Construction Council for giving me this opportunity to talk on data center subject, specifically for the project Lifecycle, cost, and design with the steel. So to begin my discussion, rather on this presentation, so I would start with saying that, like most industries, data center industries has evolved in the recent past years. I think Mr. Gupta has also speak about it in the way the growth is happening in this industry. In fact, in current central fiscal budget also, this data center industry has also given with the infrastructure status. So this will definitely give us a significant push for country's digital infrastructure. So to move on my topic on this subject, I'll just talk about the particulars which are there in this slide. I'll just take a minute to talk on our group, Capital Group. So what are the growth drivers? We have already heard from Mr. Gupta. He's given a very good inputs on the growth drivers for a DC industry. So I'll also touch upon the way we carry out the data center planning, followed by the efficiency on the data center certification, type of construction which we use, and the data center steel consumption. So these are the topics which I'll be covering in brief when we move on the subsequent slide. So starting with the about Capital End, we are Asia's largest diversified real estate group. We are headquartered in Singapore. Capital End asset under management is about 137 billion Singapore dollar. The most important point which I want to highlight is our Capital and Group has been awarded Global 100 Most Sustainable Corporation in the world in 2020. So we are quite a stable organization, and with this we are also getting into the data center business. So while we carry deep domain expertise in data center business, where we develop greenfield and brownfield data centers, and I would like to say that we do have a presence in globally for a data center. We are operating 4 data centers in Singapore, 11 in Europe, 1 in China. Back to India, we will be setting up a data centers starting from Mumbai, Chennai, Hyderabad, Bangalore, and Noida also. So we carries a good expertise or managing and operating data centers successfully from past few years also. So moving to the next slide. First I wanted to talk about what is business trends are changing in today's world. So what we say is the time has changed in the current digital world, where Mr. Gupta has also touched upon those points. Earlier, people used to adapt to technology, but today these things have changed. Technology is actually adopting to people. Obviously, with this way, I can say that customer interactions are also flipping. So in that sense, it's rightful to say that the world won't come to your IT. It's actually your IT will need to go to the world. So you can see that the way business trends are emerging in today. That's how we have seen the growth story. We just heard what are the growth drivers for India, but I'll just still touch this brief about the growth story in India. So we have witnessed in past few years data center market growth has happening around with 20 to 30% of a CAGR. So when Mr. Gupta mentioned about the growth which you have seen in past 5 years, which has become a double the capacity of 400 megawatt, and it's eventually going to touch around 3000 megawatt in next 1 decade. So you can figure out the way the growth story is happening in DC field. So which will be definitely touching around 25 to 30% of CAGR. So what are these actually growth story here? So earlier, before pandemic, if I say there are almost 400 plus or 450 million users of smartphone in India. This pandemic has actually seen the increase in subscriber. Now it has touched almost 550 to 600 million users of smartphone in India. So obviously, if I give the numbers, your data traffic has gone by 60 times in last 6-7 years, and the usage on the smartphone is also increased by 17 folds. So it actually gives the way the growth is going to happen in this field. And we have also seen there is a significant adoption of cloud services, and it's successfully implemented in the mid-sized sector also. So maybe I would like to give one example here. One of my old friend, he's in cloud services business. So he did mention some time ago, he recently could penetrate from a mixed sector to one of hospital where they get into the cloud services. It's only one hospital he actually managed to get in. Over the year, he could manage to penetrate 5% of the hospital only within these states, which I'm talking about, especially in Maharashtra. So what I'm trying to say, the mid sector is also going to contribute largely for adoption of the cloud services. So I think these are the few perspectives which are making sense for a growth story for data centers in India. There are few other demand drivers which is already touched upon, like 5G, IoT, artificial intelligence, machine learning. Of course, there are few challenges we have seen for the data center which are operating in premise, which is nothing but the captive data centers for enterprise or the mid sector industries also. But apart from the increasing their capacity requirement, what I also seen is why this is going to poise a good growth, especially from an enterprise segment. See, in this pandemic, we have seen that it was very difficult to operate for any data center which is in a shared environment. Can I say it's in-premise data center, which was difficult to manage because in this pandemic, because there was a lockdown. It was very difficult for one to arrange a manpower to run 24/7 these data center operations. Obviously, this will definitely give a increase in data center consumption over the years, but down the line, next 2 to 4 years, they will definitely give a push for a data center colo players to build very large capacities. Over and above, and there are government initiatives for Digital India as well. So when we begin, our data center, when I say data center life cycle, so it starts with the planning. When you're doing a data center planning, it starts with the market research. You do the planning for, the budgeting exercise. You do the planning for selection of the land parcel. You ensure that, the budget has been, has been captured based on your growth story. So there is the market share which is prevailing in India. So which segment do you wanted to look at it in terms of the market share? So these are some aspects of a business planning which generally we take care in the beginning of when we are starting for a business planning. Coming for the next slide. See, apart from data center site selection, since we have seen over the period, we also face a couple of challenges for carrying out the data center design. One of this is carrying out the site selection, which is just touched upon in the previous discussion. Site selection is very, very important. While we see these parameters to looked in, over and above, we also ensure that the size of the land parcel, it actually make a sense for you based on your growth story and based on your business planning. And over and above, the dimensions also makes a very important part here, because see, data centers are power guzzlers. You develop your design in the manner where utilities are just nearby your power consumption of your IT. So the efficiency plays a large importance here. We'll definitely talk on the efficiency of a data center in the form of POE, but these are very, very important aspects for carrying out the site selection, apart from the parameters which you see in this screen now. So moving on to the next slide, I think we talked on the business planning. We talked about the carrying out the site selection. Of course, there are various aspects, doing the data center design, onboarding the process of various consultants, various OEMs to ensure that data center production, a data center is live for a production. But what is important here is what exactly the timeline you see. Is it only the timeline which someone outside see that the timeline for data center build is between 17 months to 21 months? Is it only this limited to that? So maybe I'll just give you a brief that when you actually thought of setting up a DC in any continent, what it actually follows largely for the most of industries. So you do the market research. It has certain timelines into it. You also carry out the selection of the land parcel. Parallelly, you make out the due diligence of the site in order to ensure the suitability of the land. Over and above, you start working on your design process. And there is a good amount of time you spend not only in the design, you also go for authority approval. So especially when I talk about the authority approvals, which can range from 6 months to 1 year also. So the benchmark to start off your construction at site would be what once you got the EC or CTE, which is a consent to establish to begin your construction at the site, followed by the construction cycle which I mentioned, and finally with the production, the DC production is live. So from an outside industry, if you see, when I'm talking about the OEMs, he will be limited to see that when I'm able to deliver the product at site, his product, so that it can live for a DC. Maybe some service organization with respect to design, with respect to license, with respect to the various consultancy, they will just try to focus their timeline only. But if you really see in this toto, when I see this timeline, is it really the 3 years, 3.5 years, or 4 years? So I think it's a point of interpretation again. we can further optimize these timelines based on the requirement. Why I'm saying, because the data centers are also built with the in a pre-commit model, and into the as a speculative design also. But on the same time, so here just I wanted to touch upon one more thing, that when you make a business planning or do the budgeting exercise, you have to also see that what is the timeline you have taken for finally starting the data center construction at the site. Because this budgeting exercise actually create a difficulty when you are starting your construction, maybe after a year or two, and what are the changes happened that point of time. I mean, though you may be considering the contingencies with your project, but it is really suffice to take care of the inflation and and the future requirement of a data center. So we'll touch upon those points. What is really impacting today, especially I will talk about the steel. How does it actually impact from last 2 to 3 years, and where we are today in terms of the steel prices. So I wanted to touch upon that aspect as well. So as we on in terms of the design aspects of a DC, we follow the procurement strategy largely in three different three different way. One is the conventional method, which we say the item rate. Second would be the lump sum contract, and third will be the design and development, which what we call as a GC contract. See, if I look back 5 years ago, what we have seen is there is someone who's some partner who's doing data center construction separately. There is a separate partner who does your interior work. Similarly, the separate partners are there to carrying out electrical, mechanical, your LV system, and so on and so forth. But it it really finds a great difficulty for a project manager to make sure that the seamless integration happened for a data center live. So of course it's really, we have to see that a GC contract who can take all the responsibilities in order to ensure the seamless integration has happened. So what is the change, if you ask me? Of course there are many players who the data center players, they are thinking to go in this perspective, but are we really seeing those experienced DC or who can really implement the entire DC for a construction cycle requirement? It's a point of debate. But of course, in last 2-3 years, we have seen this adoption of as a GC contract in this segment. But we always say that, or rather, I always say that we learned with our experience. So as we see those experiences happening in the industry, this adoption will increase. We'll see more and more players are participating for as an GC for a data center execution. Now this is very important topic to talk on. The capital cost of DC build, and it is a very interesting slide to discuss. The chart depicts here what is the tentative percentage cost required for the various data center services equipments. You can see that, and this chart depicts minus land parcel cost. Why? Because you may have a planning for your data center in the phase manner. The land parcel may vary from one capacity, one acreage to the very large acreage also. But largely we have seen this is how the percentage tentative percentage of the data center equipment carries in terms of a cost. So when we make a business case, we generally see the capex cost hovers somewhere around 6 million or 6.5 million per megawatt of cost. When you actually because this is generally the trends which you are seeing, what is the cost what is the cost being spent in last couple of projects. So that's how the trend being followed, especially on the specific continent, and this may be different in the different geography also. So when we speak to the various stakeholders on capital cost required for DC, so they tend to work out an average cost being incurred in the recent past projects. But the fact is, it is always different from one to another project, and it's also depending on the kind of redundancy, I would say, or the kind of configuration or the kind of tier which you wanted to implement for your project, because that again, significantly varies. So before that, I would say that your MEP cost, which is minor core and shell requirement, it's hovered somewhere around 3.8 to 4.3 million US dollar per megawatt. So what I'm talking about is just more of an IT load, not on the gross load. So obviously this will vary based on your tier configuration, based on the redundancy which you want to develop, and again it goes with the pre-commit, or rather when you are making a speculative design. So obviously the cost will vary. That's how the band goes between 3.8 to 4.3 million US dollar. So while we were talking about the capital cost of DC, what is very important here is PUE, which is power usage effectiveness, which actually indicates that at what efficiency your data center is operating, and this is nothing but a ratio of your total power requirement for a data center facility versus IT load. So this PUE was introduced by GreenGrid in 2007. So when I say the ratio of total power versus IT load, so there has been discussions around from past few years that this IT load you measured at what? At a rack level. Second, at the PDU level, which is the distributing power to the racks, and third would be at a UPS level, because there will be a considerable change in terms of a PUE, because when you measure from PUE from UPS for IT load for a UPS, your losses comes in picture for your UPS and the distribution losses when it finally reaches to the rack. So it's all depending on the way you wanted to measure this PUE. But of course, what is important here is the power to be measured where you can target how efficient data center has to be designed in the beginning itself. Of course, there are parameters looked in how the efficient design can be made. So moving on to the next slide. So when I was talking about PUE, we have to look in a granular level how this PUE formula is actually comprised of. So when I say the PUE exactly, it's comprised of your electrical PUE, which is the power consumption take place, and with the mechanical PUE divided by the IT load. Why I'm talking about this, these components, because you will target these aspects when you are actually setting up a design for your data center. Why? Because let's say if I talk about the UPS losses, so obviously you will ensure that the UPS which you have selected, it comes with an optimum efficiency. Optimum efficiency in the sense, see, we create a redundancy within the data center, whether it's in n+n configuration or it's an n+1 configuration. So what you ensure is the UPS which you are selecting, at least at a capacity of 50%, it should give an optimum efficiency. So as and what important role plays in terms of equipment placement, so that you reduce the losses. For example, a data hall, if you are creating your power distribution within the floor, within the data hall area, obviously your losses will be reduced. So I think there are a lot of aspects which we can target during the design of a data center. So in order to make sure your data center is efficient and optimally designed. Data center certification, I think in recent years, which we have seen that data centers is also going for a certification. So largely we have seen the captive or enterprise data center, generally they go for this kind of a certification. So there are two certifications which we have which generally we adopt. One is the UPI and second is the TIA 942. I mean, as I said, largely it is enterprise and captive data center used to go for a certification, but this certification also helps your end client confidence for adopting industry for a design and development for good design and development practices which can give a high level of performance. But over the period, we have seen that with the speculative design, it becomes imperative to use this the certification, because that's finally gives the confidence to your end client also. Moving on to the next slide. Now we'll talk about the construction, the type of construction which we adopt when you're actually starting the groundbreaking, starting for the core and shell, designs. So you do construction in three different formats. So one is the RCC structure in the cast in situ method. One is the RCC structure in the precast, and third is the PEB with the steel structure building. Obviously, there are pros and cons. There are merits and demerits to between three. Of course, the cost is also one large factor here, but on the same time, you generally adopt these these format depending on your data center to go live. So I already talked about, if you are working on a pre-commit model, it becomes very important for you to select the format which help you to go for a data center live as early as possible, because your revenue realization starts very soon. But at the same time, if you're going with a speculated model, probably you can choose depending on the production data center production live, or maybe you rather foresee that when your customers probably look for a space over the years. So these are the advantages between these three methods of core and shell construction. Of course, there are great advantages here in terms of the steel structure when you are going with a PEB, which is a pre-engineered building with a for data center construction. But I wanted to highlight here, is it really time to time of need in terms of selecting this format for going with a steel structure? I think some of data center players has gone on a back foot to see that the price escalation which has happened in the recent times. I'll in my next slide I will talk about that. But of course, what are the great advantage here in between these three is largely, if I can say, with the pre-engineered building, your manpower is very low, and your relatively risk is also very low, because because manpower requirement is less. If you are working on a large land parcel, it actually goes well, because you need to make sure those the infrastructure that is required to erect these steel structure, you are able to make sure the space is already available. On the same time, if you see the precast, you have to also make sure that additional space is available for erecting the precast members. And there is the format which we have seen in the past that's been regularly followed with RCC structure in the cast in situ. But of course, adopting this steel structure in the recent times has really taken on a back foot, because of my the points which I wanted to highlight in terms of the cost which has escalated in last 2 to 3 years. So before I talk on this, let me give you the glimpse about how this steel has been used in terms of the data center construction, not just limited to the core and shell, also with respect to the other DC infrastructure. While you are creating a platform for a DG set, while you are creating a platform for the chillers on the terrace, over and above, the steel is also being used in almost in every equipment. And how does it actually really impact, or it's escalated your cost in the recent years? So maybe if I just give you example between the commercial building and the data center building. So if you see the steel requirement for a normal commercial building, which tends to be around 6.5 to 7 kg per square feet. So when you talk about data center which you are developing with with a 20 with a 2000 kg per square meter floor loading, with what's the largely different here is the floor loading requirement for a data center. Your steel consumption almost goes double when you are actually going with a 2000 kg per square meter. When I talk about the steel a data center with a steel structure building, this is almost 2.5 to 3 times of your steel requirement than your rather I would say double than with respect to the cast in situ. Why I wanted to highlight this with the rather emphasizing on this the steel consumption of in data center. 3 years ago, or rather 2.5 years ago, the cost of steel was touching around rather it was there at 45 rupees per kg. Today we have seen this steel cost has touched almost 70 rupees per kg. Look at the escalation. You can't imagine with this kind of escalation happening within a year or two. It's almost 60% of increase Again, another figure which I wanted to talk about here, when you are actually creating a DG infrastructure with a steel structure arrangement. So I have actually, categorized here one based on the IT load requirement. What is the, consumption of steel which you do for creating a DG structure, which is almost 18 to 22 tons for a per IT load, per megawatt of IT load. When you're talking about a gross load, it touches close to around 11 to 13 megawatt. So idea of showing these figures was, if my cost escalation is happening, which is 60% of the total cost, my total cost escalation for a data center project goes around 20 to 30%, which includes my complete life cycle of the project. Because if you see almost everything which you are which you are using in data center, it's one or the other way it's related to the steel, be it your panels, be it your the large equipments which you are using it for the site. So maybe with this forum, I would like to hear most on this. How moving forward we really see this these escalation doesn't impact or rather I would say investor really think hard on this, that this kind of escalation is really makes sense to adopt the methodology of steel construction and data center build. Of course it goes with every industry for that matter. Or shall we really limit it ourselves to do the data center with the cast and sheet method? So last, but not the least, here I will talk about the data center operation challenges. So this slide depicts, the data center efficiency is very important to address, because between 55 to 60% of your operation cost goes around energy. So it's very, very important to see the data centers are designed efficiently. You are monitoring your PUE closely, so that each aspects of the data center equipments being watched closely, where we as we do the monitoring of data centers, obviously moving on, we will closely see that how equipments are rather technology is giving opportunity to increase efficiency on the equipments which are being used in data center. So why I'm giving this example, because if you just go back 8 to 10 years ago, the UPS losses which we have seen, which was touching around 92 to 93%. Today the UPSs are available which can give you the efficiency up to 96.5 or even 97%. Why it is so important? Because moving back, we have also seen if you have a limited space for implementing the data center, we have also seen the technology being used for on a rotary UPS, where you avoid placement of a DG set within the campus. But because of constraints on the UPS efficiency over the period, we have seen that the efficiency is improved. Now no one is talking about the rotary UPS. So I think with the change in technology and change in efficiency of equipments, it will help us to improve PUE on a data center infrastructure. So so why I'm talking about the in and around energy, because one of the research papers says, as Mr. Gupta has also talked about, about the power requirement moving forward is going to touch 3,000 megawatt. So one of the research papers says is, by 2025, the total world data center power requirement will be hovering between 3 to 4% of total global energy requirement. So by seeing this figure, it's really important for any investors to see that when we are building a data center, it's actually a sustainable. Of course, we have seen this the investments happening in the renewable energy, and as we improve the efficiency of the systems, it will definitely curb the power requirement in the data centers also. So I think I just wanted to conclude here, and would like to hear any questions to be addressed. Over to you, Carol.
Thank you so much, sir, for the wonderful presentation. Moving on, before we move on to the next speaker, requesting all the attendees to please participate in the poll and post your questions in the Q&A box, which will be answered by the speaker eventually. Thank you. Our next speaker for the day is Hariom Gera, Director, Constructure Designs Private Limited. Hariom Gera is the Managing Director of Constructure Designs Private Limited. He has extensive experience in design of concrete, steel, and composite structures. His passion is sharing enthusiasm with owners, architects, and structural engineers to develop innovative solutions for complex structures involving intricate designs. Over to you, Mr. Gera. Me.
Good afternoon, everybody. Mr. Kamlesh is given a very excellent presentation regarding the life cycle cost of the total project, but I am restricted to the life cycle cost on the construction industries only. In this, when we are talking about the life cycle cost of the construction, this is divided into costing is required for. This is important understanding of the cost involved in the every project. In the basically, when you are talking about the India, in the India is the marketing is the cost-based marketing. That's why the every time first when we have started the project, any project like data center and any project, so we are cost is the most important thing in the project. How to reduce the cost and how to optimize the building, whatever. This is the everybody wants. Traditional method of a similarly look at start the cost and cash flow and profit and loss. Now we are also assessing the what is the life cycle cost of the construction. Then we will choose the technology, whatever we required, like RCC or steel industries. Primary, we are basically depending upon the manufacturing of the product, like generally in the local area, the steel is not available. Now, last 5 to 6 years, the steel is easily available, and the contractors of the steel construction is also available. That's why slowly we are going to the with the steel construction. We are going to the steel construction. Basically, in the international, when we are seeing the international market, generally the percentage of the steel construction is approximate the 65% of the total construction, and the RCC is only 15%. While it is in the India, the total 70 to 80 projects are in steel, concrete, and the only 5 to 6% are in steel. But nowadays we are going with the good technology and the faster construction, lesser labor. That's why we are switches to the steel industries. Now the cost is also involved in the pre and the post of the post construction of the building. Life cycle cost is divided into 5 parts. One is the initial cost. In the initial construction cost is included everything. Second, service cost. Third, preventive maintenance costs. Second, operating cost, and the disposal cost. The operating cost, we have Mr. Kamlesh is already discussed with you. We want to discuss with what is the cost is involvement, like your MEP, like HVAC, like electrical.
Sir, sorry to interrupt, but your slide is not changing. Can you just change the slide, please?
Now it is changing?
No, sir, not for us. It's, we cannot see the slide change. Can you just stop sharing and reshare? Probably it will change there.
Now?
No, sir.
It is okay?
Yes, sir, better.
Okay. The life cycle cost of the construction is divided into 5 parts. First is service, second preventive, third preventive maintenance, third is operating costs, 6 is disposable cost. The operating cost is already discussed, Mr. Kamlesh, Mr. Mr. Kamlesh, and I don't talk about the operating cost. Operating cost is your whatever the MEP cost. It is the operating cost. The rest of the cost we have discussed. The life cycle cost is first is your total capital, lifetime operating cost, operating maintenance, disposal cost, and last one is the disposable value, like a salvage value. When we are discussing the salvage value, the steel gives you a salvage value and the concrete is 0. We can also include the salvage cost in the life cycle cost. Why we are required the life cycle costing? First, we can understand what is the total cost during the life of the project. We can assess the management or the team to what is the cost. Second is to identify the reduction effort of the likely to more effective. Like suppose we are using a RCC steel, number of other things like walls, brickworks, dry wall panels, and depending upon the most material. The last one is the estimate the various design and supports. Like design means you can how to optimize the system, like using some passive dissipating devices like a damper or isolators. If it saves your cost, you can implement in your building also, because this is a very necessary in the data center. There is a very less requirement of the floor vibration as well as the acceleration. When we are using that technology, we can reduce the cost. What is the advantage and the disadvantage of the life cycle cost in improving? First is what is the cost forecasting. We have developed what is the total cost. Improve the awareness and the performance trend. Disadvantage, it is a time consuming. Before we start the project, construction of the project, we require the total study. That's why we require the more time compared to any other building. This is the disadvantage of life cycle cost, because everything we require. This is what is the initial cost, then the maintenance cost, then operating cost, and then last the disposal cost. That's why we require some extra time compared to any other building. Technology, definitely we require the latest technology going with the times, like drywall panel should be suitable for that kind of the project, because the block work generally we have seen the double wall on the periphery is required. In the data center, if we are using the block work or the brick work, this require the extra time as well as the cost also, because the height of the building is also the floor height of the building is the 6 meter. The block work and this block work is not stable for the 6 meter height. Then this double wall, and then we can use some structural technology, latest material technology, each and every technology. Approaches, establish the approach objectives. What kind of the objective, why we are choosing this, what is the cost of the objective. If sometimes we have seen somebody is starting, we have generally discuss about the initial cost only, not a life cycle cost. In the initial cost, maybe when we are talking about the steel is slightly looks like a higher cost. But if you are talking about the total cost, including the time period, including your town period, salvage values, labors, numbers of labors, then your cost will be less, total cost will be less. This is, I am talking about the formulate assumption also. Compare the cost rank with the alternate. So what is the difference between this technology and the that technology? Last one is investigate the capital cost constraint. Whatever the cost, suppose that we have what is the cost constraint with our hand, because in the steel, when we are doing the steel construction, we require the maximum cost at the initial stage only, not like a RCC. RCC is going on slowly. When we are talking about the steel, when you are complete the concrete building in the 1 year, and compared to steel building, it is completed in the 6 months only. You can save 50% time, you will save. In the 6 months, your cost flow is required within a 6 months instead of the 1 year. This is the capital cost constraint also. When we are compared to the steel and the concrete structure, the market share is the fabricated structure is only 5%. The rest of the world we have already discussed. This is 65 to 70%. Perception, this is a reason, this is a perception. Second one, absence of the quality. Third one, experience in the efficiency of the structural steel work, limited liability of the range of the steel section, and the third one is the concrete as well. But this all are the perception. It is the first thing. This is expensive. This is definitely the initial cost is coming higher than the concrete. But when you are talking about the last cost after the 50 year or 60 year, then this is a very cheap. It may be a 20-30% cheaper than the concrete also. So when we start the costing of the project, we can consider the life cycle cost also. The quality of the fabrication. Nowadays, the numbers of contractors are available, number of manufacturers are available. The quality is increasing slowly because the steel buildings are increasing day by day. Structural steel work also design. Nowadays structural consultants, number of structural consultants started the steel design, so it is easily available for the steel structural. Range is also available. Now the number of UB, UC section and PB sections, NPB section, general JSPL section, each and every section is easily available. Rolled section also. Nowadays the plated rate is higher and the rolled section is cheaper. Now slowly market is shifted to the rolled section, and the rolled section is very easily available, as well as the less requirement of time for the fabrication, and the contractors is also increasing. So there the contractor are not issuing in the steel construction industries. When we are talking about the sustainability with the growing construction market, the sustainability is the become and the increasing importance issue of in the construction industries. Nowadays, the London Stock Exchange has the correlated the sustainability performance of the larger companies in the UK. They're showing that the 50 most sustainable companies have the performance as one FTSE 100 index. Nowadays, this is a sustainability companies is the stock exchange gives you some economical value also. When sustainability development depend upon the three factors: environmental, social, and the economical. When we are talking about the environmental, and the steel construction industries require the less embodied energy compared to the RCC. When we are talking about the data center, in the data center, then the data center generally the span is very high, very high, like 11 by 11 grid. Second is 15 meter by 15 meter grid. Third one is 8 by 16, 17 meter grid. Okay. When we are talking about that, the sizes of the concrete sizes, concrete beam sizes is coming very high. And when we can go to the shifted to the PT beam system, and that the PT beam system also concrete is coming very high. Therefore, this sustainable RCC is less sustainable than your concrete, because the embodied energy is very higher than the steel structure. When we are talking about the 60 year of the life, this is the first cost of the extraction of the material, like steel ore, like aggregate, sand, cement. Then this is a manufacture of the production. This in the manufacturing of the under the cement, steel, then construction, then the uses, third one demolition, and the last one is the disposable. The life cycle cost, one formula is given how to calculate the life cycle cost of the structure. This is a first is the initial material cost. What is the include the RCC and the steel. Second one is the additional initial cost in the steel, like a corrosion protection or fire protection. Additional initial cost for concrete is 0, and initial material cost in the steel is higher. This, if we are bringing together, then the concrete is always 20% cheaper than the RCC. But when we are talking about the maintenance and the end life, maintenance cost in the steel structure is very less. When we are talking about the internal building, like a data center, it is the internal building enclosed by the walls. Then the maintenance required for the internal material. When we are talking about the steel, it's required every 20 years. When we talking about the RCC, it's required every 10 years. In the 10 year, you can check. In 10 year, you can check any cracks doesn't develop in the RCC, because there the loading is very high. Maybe a creep, maybe a due to creep, maybe a due to long time shrinkage, the crack will develop in the RCC structure, because we are calculating based on our past experience and the data center past experience. The last data center is generally construction in the started from last 20-30 years, not less, not before that. We have a experience of 20-30 years, not of 50-60 years. That's why maybe possible, because concrete is deteriorated with the time. That's why maybe possibility the cracks and the corrosion and the carbonation is started in the concrete. When we are choosing the poor quality of the water at the time of the construction in RCC structure, that's also implicate your higher maintenance cost. So maintenance cost is the lesser in the steel building. Like we have just started the multi-story building last 30-40 years back, not before. But we have a steel structure 150 years ago. This is the constructed by the Britishers in the India, like one bridges in the Delhi. This is the 100-year-old. It is working so far. But we have checked when we are talking about the RCC structure. It is after the 50 years, it may require or may not demolition of the complete project. In the cases of the bridge, this is the 100%, but we are talking about the building. Maybe the building life of the RCC is maybe increased by the 10 years, but when talking about the steel, it may be increased by the next 50 years also. So you can, when we are talking about the steel, the life of the steel building is much, much higher than the concrete building, because the property of the steel doesn't change with the time. Because this is in the data center, the total load is almost 90% load is act like a dead load, not a live load. There is the cyclic load is lesser. When you are talking about the cyclic loading, the steel response is much, much better than your RCC also. That's why we are taking this concrete maintenance cost is much, much lesser during the total life. And when we are using the steel, the life of the structure will increase tremendously compared to the RCC building. When we are talking now, we are talking about the demolition and the residual cost. The demolition cost of the concrete building is much, much higher, and the steel is lesser. Last is the residual value. Suppose we are using the 100 rupees cost in the steel structure now. Maybe this after the 10-15 years, this 100 rupees is backed by the only 70-65 rupees. So this residual cost also more important when you are calculating the cost of the structure. And I request to all the developers and all the industries maker in this line to you just including the cost of everything, not we are talking about the initial cost. And last, we are talking about what is the cost difference between the RCC and the steel structure during the concrete difference between the concrete and the RCC structure for the data center. When we are discussing this cost 11 by 11 meter panel, or second is 15 meter by 15 meter, third is 8 by 16 meter cost. When we are discussing about the 11 by 11 meter, the initial cost of the steel structure is around 1600 rupees per square feet, and the RCC cost is coming around 1450. This is the difference of 11 by meter grade is initial cost is only 100 to 150 rupees, not more than that. When we are talking about the 15 meter by 15 by 15 meter, this cost will reduce. In the steel construction, this is the approximately cost is coming 2250 rupees per square feet, and compared to RCC building, it is coming 2200, because the 11 meter or 15 meter by 15 meter, the mass of the building is very high. The cost of when the weight of the building is very high, the foundation cost will increase, column cost will increase, and the one most important thing, the RCC column cost is higher than the composite column cost. In composite, in case column cost, okay, it is the difference is almost double, or maybe sometimes there is a 2.5 times. Okay, that's why we are referring the we can choose the composite construction in the data center, because the total load of the building is increasing tremendously. In the RCC building, the total load says 100 ton. When we are going to the composite building, it's maybe a 40 to 50 ton only. We have reduced the mass 40 to 50%. Okay, then we are reducing the mass of 40 to 50%. Foundation cost is saving, column cost is saving. At last, if the building is the seismic zone, the seismic forces is almost 50% compared to RCC building. Then it is the less impact of the seismic forces. That's why the overall cost, when we are talking about 15 meter by 15 meter grid or 8 by 16 meter grid, is the difference between the RCC and the steel structure is very, very less due to the weight of the structure. So I am recommending when we are going to the data center, the steel composite construction is better than RCC structure. Thank you. Thank you, everybody.
Thank you so much, sir, for the wonderful presentation. Before we move on to the next session, requesting you all to please participate in the poll and post your questions in the chat box. Also would like to bring to your notice that MX Business Media along with ISSC will be rolling out a novel and interesting exhibition in the month of November to be called as Steel Structures and Metal Buildings Expo, along with SSMB Awards, which is celebrating the best in steel. The exhibition will be a 3-day grandeur wherein the entire steel industry would gather, interact, and of course exhibit. To know more about the pavilions and exhibition stalls, do write to sapna@mxbm.in, ssmb@mxbm.in, details in the chat box. Also to know about the latest updates in the steel construction industry and to access to the SCS videos, to subscribe to SCS TV, link in the chat box. Thank you. Let us now move on to the next speaker of the day. Our first speaker of this session is Mr. Scott Fretwell, Group Business Development Manager, Cellulosic PFP Hempel. Starting with one of the largest steel fabricators, structural engineers in UK, Scott has worked through purchasing, production, and estimating to sales and key account management with a major global paint manufacturer, then as sales directing manager and offsite shot blasting and painting contractor. For the last 7 years, his main focus is on cellulosic fire protection market, and he's currently the Group Business Development Manager for cellulosic fire protection for Hempel. May I please welcome Mr. Fretwell? Over to you, Mr. Scott Fretwell. Thank you.
Thank you, Carol, and I hope you can hear me okay and you're able to see my presentation.
Yes,
okay?
I can see the presentation.
Fantastic. So thank you for the opportunity to present to you all today. We want to share some of our learnings, our experiences with our involvement in data centers across the world over the past 5-10 years. Just to introduce Hempel, we've been in business over 100 years, supplying coatings for the decorative, protective, energy, infrastructure, industrial, marine and yacht market, and we're headquartered in Copenhagen, Denmark. The company currently employs over 6,500 people in more than 100 countries, and we have R&D facilities and factories across the world. Hempel is a company which is solely owned by the Hempel Foundation, which supports cultural, humanitarian and scientific ventures around the world. Not to go into too much, but we've got 130 warehouses, 30 factories. We're serving customers in over 100 countries, 14 R&D centers, and many, many coating advisors available throughout the world. We are a true global organization, and we manage projects and complexities on a daily basis. We also have dedicated global key account functions to ensure multinational coordination and a multinational approach. And many times we see projects constructed in one place and erected in another. This is our daily business, working with all our global customers. As a company, we also take sustainability very important, and we're one of the more than 2,000 companies worldwide which are leading the zero carbon transition by setting emissions reduction targets to the Science Based Targets Initiative. This is really to focus on rapid, deep emission cuts, setting near and long-term achievable and realistic targets, and also no net zero claims until all our targets are met. And one thing we will touch on later in the presentation as well is how we as a paint manufacturer can go beyond the value chain regarding sustainability. As you can see, we have set a 5-year ambition plan, making sustainability our key driver for innovation, to promote inclusion and diversity, to be carbon neutral, to create a framework for equal pay, equal work and insurance, and also roadmaps for products and packaging to make sure we've got the sustainable and innovative solutions moving forward as well. So our experience as a paint company with data centers. Well, first of all, why are we protecting steel from fire? We know that structural steel will lose strength at elevated temperatures. So here you can see at ambient temperature, the steel retains 100% of its value. However, you can see as we start increasing the temperature of the steel, the retention of strength is reduced. Here, we only have 550 degrees C, we only have 60% of the steel strength left. And if that fire is allowed to continue further to 630 degrees C, you can see we now lose 60% of its strength. And again, if the fire is allowed to continue, the steel will continue losing strength. And we want to limit this temperature rise in steel to prevent steel structures losing stability in the event of a fire. This is important for personnel protection. We want to get people out the building, and we also want to get people in the building, emergency responders, to tackle the fire. We protect steel from fire for asset protection. We cannot rebuild buildings every time there's a fire. So maintaining that structural stability of the building after a fire is also important. And it's also the contents and assets within the building also need to be protected. And obviously there's also legislation. Countries around the world have their own legislation on how we should fire protect steel buildings. So Hempel over the years have provided lots of intumescent coating protection to many data center projects for many different customers. And these are the majority of global data center projects. We have many completed and we have many currently ongoing. But when we started getting involved in data centers, we found it's a little bit more complex than normal buildings. We obviously need to protect the building and both its human and electronic assets. And this can be quite complex. In addition to protecting the steel structure, we have to make considerations for the building contents, and especially protection of the electronic elements from dust creation during and after construction, and also involved in fire protection. We have a range of intumescent coatings which are suitably designed to be used in such conditions, ensuring application can be done off-site if required, and that dust suppression can be maintained during operational times. And when we talk about dust suppression, it's not something we really link with coatings, but it's really a key area when we look at fire protection. And the gentleman before me, I spoke about the efficiencies of data centers and the reliability of data centers. Dust suppression is a key one. We know dust particles contain moisture, organic material, and various minerals and chemicals. And all of those will greatly affect the reliability and lifespan of the average computer if overexposed. Dust contains conducting material and metallic elements, which can lead to signal errors and abrupt part failures. And internal dust accumulation is one of the main principles of premature failure and reliability. We also see, and we've talked about, I see some of the questions also around about maintenance of heat. But when in contact, dust also acts like an insulating blanket, which prevents the necessary circuits from cooling. This again can cause overheating and electrical shorts. And it's proven that temperature can increase by nearly 30 degrees Fahrenheit due to the buildup of dust. This is significant and can lead to complete failure. Ingestion of dust into the computer processors also needs to be minimized in order to avoid serious electrical problems. So why is that important when we look at fire protection? Well, obviously, when we see on the market, we see the general key technologies used in fire protection. We have cement sprays. And again, when we look at cement sprays, we look at application on site. There is constant movement from the steel structure, which creates cracking, even after installation and movement of the structure. And with cement sprays, you always get the element of dust, and the cracking creates more and more dust as it goes into its service life. Cementitious sprays are also not top coatable, so we can't limit that dust creation. The other possibility for fire protection is fireboards. But again, these have to be installed on site. And we know that these are fitted, these are chopped, these are cut on site. And again, it leads to a high level of dust suppression required. However, with intumescent properties, intumescent coatings and their properties, this is negated. Intumescent technology creates a low installation cost. It allows for more open building design. Its use of different steel sizes and shapes adapts to shape and flexion. So there's no cracking like we get in cement, no movement. It's fairly damage resistant. There's a very low risk of corrosion under the installation compared to board and to cementitious spray. Importantly, it can be applied on or off site, and it offers little or no dust suppression. Intumescent coatings can be applied in shop, touched upon site, and they also be top coated. And also, when we look at intumescent coatings, we're adding a low thickness or a low weight compared to other solutions on the market. So we really see, as we've investigated the data center market, the use of intumescent coatings are key for many, many aspects. But why should we care about paint? You know, we see many times, and we've had many conversations with engineers and architects that, you know, it's a contractor decision, it's a generic specification of fine, and it is a small part of the project. But as we've just proven, when we look at the application of any fire protection system in data centers, we have to have key considerations on dust suppression and protection. And what we also see moving forward in reality is building sustainability and cost effectiveness is complex. A common example we have seen when there's no alignment or optimization of steel and passive fire protection is that through sustainability in steel, we use lighter steel sections being specified and used. But does this work? Because when we start using very light steel work, we see, and in cases sometimes 3, maybe 6 millimeter beams or hollow sections, this steel itself starts requiring a higher level of a thicker passive fire protection, perhaps greater than the steel thickness itself. Is this the most optimized solution for sustainability and cost effectiveness? I think in our work with engineers and architects across the globe, it's not. And we've worked very closely with engineers and architects at design stage and engineering stage to make sure that full holistic synergy between fire protection and steel design. And when we start looking at steel and fire design together, this can bring many added benefits to any project. A commercial, on the site program, and also sustainability. So what value can we bring, or what value have we brought in the past as a paint company to the data center market? Well, we've produced reduction of project costs. We have our own in-house fire engineer, which work with engineers and designers across the world to make sure that synergy, holistic view of fire protection and steel. We have a global product supply availability with consistent quality. As you've seen on probably the early slides as well, we have experienced technical services ensuring quality of application and performance available globally. With fire engineering, we can look at lower paint thicknesses, reducing material costs and application. And we have a global experience and knowledge of fire protection and the data center market. By getting in at an early stage as well, we can also bring advantages to the site program. Our products and the consistency, reduce downtime. All our fire protection factories are audited and third-party accredited. Our technical service guides ensure quality of application and performance. And we can start reducing process times. We can look at the specification of faster curing products, faster overcoating products. All these ensuring faster throughput and project handover. And what also presents is a reduction of energy and cost used during application. By fire engineering, working with designers and architects, lower paint thicknesses reduce site touch-up and rectification, reducing tail-end downtime. We can also look on the sustainability aspect, and this is when we call going beyond what we do daily with SBTI. We look at the reduction of embodied carbon when we look at holistic steel and the PFP synergy. specification of sustainability and green coatings and building solutions moving forward. We're generally working with environmental lead and BREEAM specifications. And when we talk about reduction of material requirements, we talk about reduced dry film thicknesses. The project's requiring a reduced level of coatings, which means it's less product manufacturing for ourselves, there's less transportation to the application site, there's less waste, empty tins and landfill, and reducing the thicknesses reduces the possibility of over-application. By putting on less, we're reducing energy during the application process. And less product, less VOC, and less carbon emissions really make sustainability key when we look at data centers. And I think we should all consider the full costs of passive fire protection, the steel synergy, and sustainability. And what else can we bring as a company? We bring experience. Empl are a global company with huge experience with fire protection, anti-corrosion specifications, and experience. Whether it's energy infrastructure, whether it's marine, whether it's anti-corrosion specifications, we have a big track history as a company in working involved in major projects, supplying major projects, and working with some of the major engineers, architects, applicators, and fabricators. What experience can we bring regarding data centers? Well, again, we've shared that we've worked for in the past, and we still work today for the majority of the global data center companies. And here you can see some of the projects completed throughout Europe, the Middle East, and the South and East Asia market, including Australia. And we have many more data centers due to be completed in the coming months and years also. So we bring a wealth of experience and a wealth of help and advice to all companies. And we do try to create additional value for data centers. And again, we agree with the previous speakers, this is a growing market across the globe. And therefore, we need a global approach, a coordinated global approach. At Hempel, there will be a single point of contact, focused technical resource. We have much experience in cross-border and pan-continental projects, multi-level relationships, again, with its applicator, fabricator, engineer, designer. And we have the global consistency and product assortment. All our products, our fire protection products, are designed to cover all steel sections. So it's not multi-product. One product will provide a solution. We're also able to share our best practices, things we've experienced and learned to help to those learnings and experiences moving forward as well. And we have optimized support. We have high productivity coating systems. This is anti-corrosive and fire protection. We spoke about the inspection and support for customer quality assurance and quality control. We could also provide subcontract training to ensure quality coating application. And what we've really seen proven in the last few years, especially with data centers, is that we have in Spain our in-house fire engineering design and support facility. We have a purpose-built PFP facility full of chemists, scientists, fire engineers who are working with designers and architects, engineers on a daily basis to really link synergies between fire protection and steel production and steel use. We also have technology department. We know where our systems go, our products go, and we're even working now with some major customers to try and improve uptime on solutions and have co-development of technology to make sure that our products really fit the market they go into. To jointly address corrosion issues, we know under fireboard, we know under cement sprays, for instance, that there's a higher risk of corrosion under insulation. With our Intumescent coating specifications, we can really jointly address this and minimize that. And we're also globally involved in research partnerships and sustainability partnerships, as you mentioned also. So we bring a lot of wealth and experience to the data center market, and we have a lot of experience within Hempel on fire protection and anti-corrosive specifications. and really that synergy between steel design and fire protection to make sure we can utilize the most efficient and holistic view on fire protection and steel. I thank you for your time. Just on screen, I share my contacts and a few other contacts within Hempel if you have any questions or any future support or require any future assistance as well. So thank you very much for your time.
Thank you so much, Mr. Fretwell, for the presentation. Moving on is our next speaker for the day, Dhruv Mahimtura, structural consultant, Mahimtura Consultant Private Limited, and MSc General Structural Engineer from Imperial College London and BSc Civil Engineering from University of California. Dhruva is currently working at Mahimtura Consultant. He's responsible for design and construction of RCC and steel structures and roads for preparing project reports, feasibility studies involved in analysis, design, and repair coordination. He's a member of PETA, Bombay, member of the Institution of Engineers, and many more professional bodies. Over to you, Dhruv. Thank you.
Thank you, Carol. Just want to confirm, can you see my screen?
Yes, I can see the screen.
Yeah, is it changing?
Yes.
Okay, all right. So just a brief introduction of our company, Mahimtura Consultants Private Limited. It's a third generation company started by my grandfather in 1949. We have over 70 years of experience, and we started our project management branch in 1997. This is our pan-India, existence. We have our head office in Bombay, as well as Pune. Those are our two design centers, and then we have satellite offices in the rest of India. These are the addresses of those offices. So yeah, it was started by my grandfather, taken forward by my father and my uncle, and now the third generation has come in. All of us are grads from either the US or the UK. And some of our esteemed clients, these are government clients. We have our corporate clients as well. And these are expertise that we have in engineering. So we do all kinds of civil engineering, all the way from repairs and rehabilitation, as well as project management. And these are the different types of structures that we have tackled before and have expertise with. So just coming on to our topic, it's a slightly off topic, but something that's pretty interesting. We have done an upgradation of a regular commercial IT building to a data center building. Currently, phase 3 of this project is going on, but we've completed the first 2 phases of this project. This is where it is. It's in Panvel. Brief introduction. It was initially constructed in 2016 with 1 million square feet. And then the client didn't have any sales of that commercial building, so they decided to convert it into a data center. It's got a basement, 3 podiums, and then 12 stories, which was originally designed for commercial loading. The grid is about 10.8 meters by 10.85 meters and comprises of post-tension slabs with an earlier flat slab and column drop kind of a system. The floor plate, typical floor plate is about 4,000 square meters, and the basement is 6,800. And the podium and basement is actually connected with another commercial building, which is slightly taller than this one. So this was our brief. We had to convert this commercial IT building into a data center. And basically every alternate floor had to be upgraded to take a loading of 1,500 kg per meter square. And then you had the battery floors, which were the data center floors, and you had your battery floors, which had slightly lesser loading, 875 kg per meter square. And we had to upgrade it from the 400 kg per meter square live load. In addition to that, there was a transformer added at the first podium slab, and then a chiller platform on top of the terrace. So we had to do that as well. And since we were, upgrading the structure, we had to upgrade it to the latest IS codes. So as per the 1893/2016 code, we had to jack up the importance factor to an importance factor of 1.5. So what we started off with was some non-destructive testing as well as a load test. We carried this out because the building was left on its own as is for a couple of years. So we had to ascertain the existing strength of the building and then use those inputs in our analysis. We also carried out a load test. This is pretty important because we had to benchmark ourselves and see where we were starting off from, whether the existing slab could take that live load of 400 kg per meter square or not. So that was done in 2 bays on one of the data center floors. And we found our results to be satisfactory in terms of the NDT testing as well as the load test. A little bit of a design brief, it's in the seismic zone 3. Now we had an importance factor of 1.5. We had to also look at fire rating of any kind of steel members that we were going to use in the upgradation process. So we decided to benchmark it with a 2-hour fire rating for all of those steel members. We also looked at the soil bearing capacity because now we were upgrading the load. So we had to check the foundations, but we had a good SBC because there was hard rock already available at the site. And the existing structural system was basically RCC column beam frame system with the shear lift and staircase shear walls taking all of the lateral forces. We had a PT drop system with edge beams. Only the toilet blocks were constructed with a conventional RCC beam slab system. Certain grades of concrete that were there, these were already existing. And then the non-structural wall thicknesses that were also there. Steel grade, regular RCC steel was Fe500. And then these were the existing loadings that we had. So our regular office floor load comprised of about 6.75 kilonewton per meter square. And we had to upgrade that to about 15 kilonewton per meter square. So this was basically what we were upgrading the structure to. Just want to point out the data center floor, that's what we're focusing on right now. That is a total live load of 15 kilonewton per meter square with a fixed live load of 10 and then a reducible live load of 5 kilonewton per meter square. And then the chiller platform coming on top of that, which also had to take 10 kilonewton per meter square. And then you have the fixed component of 8 kilonewton per meter square and reducible live load of 2 kilonewton per meter square. This was the kind of strengthening measures that we had to input and do and carry out on site. So we had to jacket the foundations because the overall loading of the building had gone up. The importance factor of the building had gone up. So we opened up each and every foundation of each and every column. The shear wall combined footing foundations were okay on its own, but the individual ones were the ones we had to tackle. And those were the ones we had to jacket with reinforcement, with proper drilling and getting shear anchors to do a proper connection. We also jacketed the regular columns and the shear walls with about 200 mm thickness. We used M55, in some places micro concrete, and in other places regular concrete. And then for the data center floor, we had to tackle strengthening from the bottom as well as from the top of the slab. So the bottom of the slab was strengthened by the use of structural steel I-beams, as well as a normal carbon fiber wrapping. And then the top of the slab, we had carbon rods along with pre-stressed laminates. And then we had a 75 mm screed topping on top of all of that, which was a reinforced screed as well. So we could increase the overall depth of the slab. And then the chiller platforms on the top. So we had column stubs from before. We used those column stubs, put a base plate on it, jacketed those sizes of the columns. After putting the base plate, we erected I columns and plate columns with concrete infill. And then after that, we did our connection of the steel grid for the chiller platform. And then we micro concreted the entire and basically created a composite column to support the chiller platform. So this is basically a typical floor plan before strengthening of a data center floor. As you can see, you have your column drops and a flat slab kind of a system. And then this is what we did after the strengthening. This is from the bottom of the slab. So you can see we have primary and secondary beams. The primary steel beams were about 450 mm wide by 700 mm deep, and the secondary beams were 450 mm wide but 600 deep. And we used 350 grade structural steel. And this was the kind of strengthening that we did from the top of the slab of the data center. So you can see our reinforced screening that's coming on top. And then we had the carbon rods in the drop cap area. And we had our active pre-stress and non-active normal carbon laminates as well on the top, which get encased in that 75 mm screen. We did our overall analysis in ETABS, so just some photos from our ETAB model. And then these are actual photos on site. Just wanted to include these to actually show you how the execution was done. So this is the overall footing strengthening that we did, along with the column jacketing that was started from the foundation. And then you have your columns before and your columns after. So you can see the difference in the column jacketing, and we also fiber wrapped the columns after we were done jacketing that. And then this was a before and after pic as well. On the left side, you can see your regular column drop, and then on the right side, you can see how we've connected these I-beams used for the strengthening measures from the bottom to the existing column, and then we encased that in the jacketing. So we created a proper fixed end condition as well. Photos of the slab before as well as after. So these are the regular carbon fiber wrap that's there on the slab in both directions. And then the white board that you see on top of that is the fire board that we put for fire protection. This photo is particularly interesting because it shows the type of fire rating that we had done to those eye sections. We use a vermiculate paint over here. You could also have used an Intumescent paint, but we did a vermiculate spray just because aesthetically the client didn't really have any issues with leaving it the way it was with a vermiculate spray. And then on the right photo, you can see how your main beams that are connecting to these columns at the column drop, how we basically welded this and created a proper connection. And then we had to use packing plates in certain locations to cover up the, any sorts of gaps that were there. Another photo of, our I-beams with the vermiculate spray done. And then you have your carbon fiber wrap. And then on the right side, you can see how the fire board is placed on top of that as well. So this is the floor slab that we basically inherited. And this is the topping that was done from the top. So you can see your active pre-stressed laminates as well as your normal laminates that are there. This was I'll just point out that these laminates were used to take care of the negative moment that was coming. And then you have a finished screening on top, your carbon fiber rods in the column drop area. And then the 75 mm screening on top of that. So this is the chiller platform layout, supporting layout, also done in structural steel. Many more beams over here, but this was a lot of back and forth that we had with the client because they had headroom issues. So we had to decrease the overall span to reduce the depths of these beams so that we could achieve the proper headroom. And then these are just some details to show you the kind of detailing that was done in terms of the drawing, in terms of the drawing, and then fabrication drawings were made after that. This is what we inherited before, and then you can see the final product on the right, bottom right, for the chiller platform. And then you have the final product as well. On the top, these beams were painted with zinc, and all of these beams were hot dip galvanized as well. We had a zinc epoxy coating. And just some quality control that was done on site. We had to measure the thickness of the vermiculate spray. Since we were doing that 75 mm screening, we had to look at certain quality control. And then just to conclude, what we did was we had to ascertain whether this upgradation could take that 1500 kg per meter square loading. So we redid the load test in that same column grid, those same 2 bays on the second floor. And we did achieve that. Overall, the first phase was about 4 floors of this overall building, including the foundation jacketing. So that was, for the survey time, the testing time, the design and tender time, it was done in 3 months. And then the overall completion after that, in terms of construction, was done in 6 months. So it shows that it was done fairly quickly. And the main purpose of upgradation from the commercial building to a data center building was to save time. And that was the ultimate goal, because the client did have a vendor on board, and therefore we did it the way we did it. Thank you. Over to you, Carol.
Thank you so much, Dhruv, for the presentation. Requesting all the attendees, I said earlier, to please post your question in the chat box. Also do participate in the poll. Let us now move to the most awaited session of the day, the panel discussion. Let me start with first welcoming the moderator, Girish Dravid, Director, Sterling Engineering Consultancy Services Private Limited. Now our speakers, Hiten Maimtura, Director, Maimtura Consultants Private Limited, Sanjay Kuntal, Head DC Projects, Yota Infrastructure Solutions LLP, Hariom Gera, Director, Construction Designs Private Limited, Kamlesh Harchandani, Head Design and Development Projects Capital Land, Scott Fredwell, Group Business Development Manager, Cellulosic PFP Hempel, Tarun Kumar, Regional BDM, Cellulosic PFP S&EA Hempel. Before I hand over the session, as said earlier, please post your question in the chat box. Will be taken over by the moderator eventually. Over to you, sir. Requesting all the speakers to please put on your cameras.
Yeah, please come on the screen. Hi, Hiten.
Hi, Girish. How are you?
I'm fine, Hiten.
Hello, everyone. Good afternoon to all.
Hello, Kamlesh.
Hi.
Hi, good afternoon, everyone.
Hi, Sanjay.
Hi. Good afternoon, everybody, sir.
Hi. Hello, Mr. Gera.
Hello.
Good afternoon.
Yeah, you gave a great presentation, Hariom.
Oh, thank you.
Yeah. Okay, so
Thank
all
you.
of there. I can't see Scott here.
Hi.
Scott, hi, Scott.
Hi there.
Okay, I think Anil Bansal is not there. Is that correct, Carol?
Yes, sir, he's not there.
And Tarun?
Tarun is there. Tarun, can you put on your camera on, please?
Hello, hi everyone.
Hi, Tarun. So I can see Hiten, Hariom, Gera, Tarun, Scott, Sanjay, and Kamlesh. Okay, fine. So we are there. The presentations are great, and starting with what data center is all about, starting with Sunil Gupta, and then Mr. Prasad. We then came down to structural the data centers, and we got a lot of sort of summarizing, because all of these points were actually covered by all of you. But I would like to request you that even if your responses are tilting towards negativity in terms of using steel for data centers, please voice them out, because that is the way we will all know what issues need to be addressed. And that is how we can promote steel, addressing those issues and convincing the client that, yes, we know these problems, but we can address these points. So I'll start with the fundamental question is, does the choice of construction material really matter in a data center? And I want to put this question straight to Scott first. Scott?
I think, as we've seen in presentations, I think we're using steel within data centers clearly improves the timeline. And I think the flexibility of steel construction and the protection of steel construction, and also as we move forward, the sustainability of buildings is really key moving forward as well.
Right.
That for me, really, steel is the way to go.
Okay, so you actually recommend steel to be used in data centers. Is that what I gather?
We don't, as a painting company, we don't recommend, but we've been involved in various data centers at various different levels.
Mm-hmm.
And what we see traditionally around the world when we've done data centers is that steel is the primary choice of construction material.
Okay, okay. But I just want to extend this question further because there is always a debate on steel, concrete, and all that. And generally, the comparisons are between cost and time. Okay. But considering the delicate nature of this equipment, which can be affected by magnetism and metallic surfaces and all that, are there any adverse effects of using steel in data centers? As regards metallic or magnetic effects, has any research been done? Is there a long-term record of durability of this equipment in steel structures?
For me, not that I know about, but I think we've got more experienced and more knowledgeable colleagues on the call, which may be able to answer that as well.
Yeah, fine. So I'll shift this to maybe engineers. Hiten, can you answer this question? Have you experienced or have you heard from clients that there are any adverse effects of steel?
Actually, these racks today, which we have as servers, they are all metal. They are steel racks.
Right.
And therefore, your disk inside will not make a magnetic effect, or I don't think should create an issue, because as it is, your servers are also protected. Which we call the server racks are all metal itself.
Right.
So I don't see any problem in having a steel structure and affecting the servers or the disks or whatever magnetic effect as you call it. This is what I
fine. Right. Anyone else has any different opinion on this? Otherwise, I'll move to next question. So, if in that case, we are now talking only of the comparatives between, involving cost and time. And many of the speakers have already spoken about that. There is another effect of steel that comes to my mind is the vibrations. The steel is quite, it's a flexible material and prone to vibrations. And will this affect the equipment more than vibrations in RCC structures?
Shall I give?
Yeah.
Whenever we are talking about the vibration, in the case of the RCC, also in the case of the steel, whichever building you will choose, you can check the vibration.
Yes.
Whatever the limitation is there, we can design the building accordingly. So the vibration is not an issue for in the case of designing.
That's right.
Correct.
So which means we will design to the limits of the vibrations. Those are imposed by TIA or whoever the organization is what you're saying.
Correct. And
yeah, but
it is the better.
Yeah, in that case, in that case, using the materials and all that. So in all this process, will it be more costly, or will it be costlier than the RCC structure?
When we are talking about the 11 meter by 11 meter grade, definitely the slightly costlier. Okay, this is the initial cost.
Okay? That is initial,
yeah. Initial cost is definitely slightly higher than the RCC structure. When you are talking about the 15 meter by 15 meter or 8 by 16 meter grade, okay, then it dictates that this is a plus minus 5% or 6%. Maybe the RCC is 5% costlier, maybe a steel is 5% costlier. This
Okay.
is depending upon your architecture or depending upon your server layouts.
Right.
But when you are talking about the operating cost, when we are started the steel building, okay, in the steel building we have taken the advantage of the everything. This is a fastlier construction, shallower depth, okay, and then we are talking about the peripheral material also. When this is a 6-meter high story height, and we have already discussed this is the block work is not possible with the 6-year height without mullion and transom. Okay?
Right.
So you can go for the drywall panel system.
Right.
Any type of drywall panel system with the cementitious board, MGO board, number of materials are available. And when you are choosing the drywall panels, your energy consumption will less because your penetration of the heat is much lesser than compared to the block. Okay. So I prefer when you are using the steel building, you can choose the drywall system so that your construction will much faster than compared to imagination.
Right.
When the client is coming to a picture in the data center, he wants the building the complete within the 6-7 months. And this type of the building is only possible in the steel, not in RCC. Because when the RCC is using, this is the double height shuttering is there. Beam sizes is coming 1000 by 1000 or 1500 by 1000 when we are choosing the pre-stress. This is a impossible task in the RCC.
That's right.
Basically, also what I feel, when you're talking, there are two types of data centers which you are making. One is a data center where the generator rooms, panels, and all that are in another building itself. They have a generator room building. But they are doing data centers where everything is inbuilt in-house. So there you will have to design with the codal requirements on vibrations and all that, because there otherwise normally in a data center, in fact, the human traffic is because of security is very less. The movement of human is very less in the regular data centers. So wherever we have in a complete combined captive, where you have generator, you have everything in that one building, there is where you actually have to look at the design and codal requirements as per TI, whatever, you're all, so those, and that can easily be designed, which would also would have to be done for RCC building. So it's what I'm saying. It's
of course
stackable. There's no issue regarding that vibration. It can always be designed.
Right.
And only for partition walls, as Gera said, is inside you can use lightweight, but the external wall will have to be a proper, because for the insulation, you cannot compromise on that. So there you have to have a proper wall. But apart from that, inside you can do like, MGO boards or whatever and do for lightweight. So you don't create so much of dead weight onto the slab.
Right. Perfect. Yeah. So that was about, the mechanical engineering aspects of using steel and how they affect the functioning of equipment. But now the all-time favorite subject, and everybody has talked about it, is the commercial comparison. But I just want to give a slight twist, and I want to go to Kamleshji. Being a project manager, how do you see the economics of steel usage in a data center work in terms of not only the cost comparison, but comparing other factors as well? What from project management point of view?
Sure. Thank you, Mr. Girish. So maybe, I'll just talk about the tangible benefits, using the steel PEB pre-engineered building versus, the RCC casting sheet method. So definitely the biggest advantage, which Mr. Hariom and Hiten talked about also, the timeline of a construction, it's become very short. While Mr. Hariom says it's 6 to 7 months, then a year, a kind of a building which is G+4 or G+5. I tend to agree and disagree also. Not this 6 to 7, but practically what I've seen is, yes, it actually gives a good benefit in terms of a timeline, for sure about that. But I can say it's largely somewhere between it gives you advantage of 3 to 4 months. This is one. And And if I say that the steel construction building, since this fabrication is done in the controlled environment, obviously the quality is much more assured, right? So this is the second big advantage if I see. Now, over and above, what I can see the foremost advantage. See, when you are making a steel structure building, your the slab is casted with the help of your corrugated deck sheet, right?
Yeah, that's right.
In the recent past, what we have seen is when the data, right? So when you're setting up a data center, couple of years ago, we used to have a false ceiling within the data center area. Now these are exposed to the slab. The height which we tend to go up to 6 meters, 7 meters. In some cases, some hyperscalers look at it even 8 meter floor to floor height also. So when you're on exposed, what I'm exposed to the RCC structure. Why? Because down below you have a IT hardware which is operating for 24/7, right? Over the periods, what has been observed because of the RCC, slab or RCC structure, dust penetration may happen over the period, and this is very, very dangerous. May create a difficult, and it can harm my IT hardware. I mean, you can think of the cost of the hardware which would probably 2.5 to 3 times your project value of DC. I think this is what I see the very good advantage over and above.
Kamlesh, this was never thought of. I mean, I don't know whether other people have thought about this, but this is certainly a new point for me.
Sure. I mean,
yeah.
See, any dust. So, okay, now I'll give you another example here. Since, my colleague Sanjay is also there. So previously, I'm sure one or the other way you must have observed, if you have really seen data center in the past, people used to never, take their shoes along in the data center when you are entering the data center. So what you do is you take out your shoes outside your data hall so that your dust penetration is not happening inside a data. So that means this is a threat to your IT hardware which is being hosted in the data center. So I mean, there was a research talks about 80% of a dust penetration happens by the people who make a movement within the data hall. It's because of the shoes which they take along with the data hall. So largely you reduce. So that's why see most of the data center they have a separate shoes putting outside or slippers putting outside just before a data hall entry, so that you don't carry forward this within the data hall. And largely, as I said, and I'm sure since you are you guys are very expert in or even especially on the slab, which can directly expose to my IT hardware, where I'm not putting any false ceiling over and above.
I see. That's good. So, but can you now shift to economics?
Sure. It's good, it's very important to discuss on. See, if I can say, the practical aspect of it, 3 years ago, okay, look at, the data center planning which you do. How does the planning happen? The planning happens much, begin with the market research, because any FDI or any investor, not just forget about from India, any investors coming from outside, he ensures that he carry out the market research. What is the capacity being required over the years? When you make a market research, you also realize that what is the capacity is being looked over a decade. What Mr. Sunil Gupta talked about, we are seeing this capacity being 10 times from now in one decade, right? So obviously this will help you to increase think about what is the market share you are targeting about. Okay, now when I'm making a planning or taking budget approval of the same, obviously the when you seek an investor to invest in the data center, so you actually take a budgeting planning much in advance, which may be 2 years down, 2 years before when you're starting groundbreaking at the site. Why? Because let's say the budget is approved, you are started your design process. After doing a design process, you are going with the local authority approval 12 months, doesn't go below 1.5 years starting from your concept plan. So by the time you reach 1.5 year, or the experience which I have seen in last 2 years, where the steel prices touch from 45 rupees per kg to 70 rupees per kg. And please recall my numbers, which I specifically said is your steel consumption in data center with the cast and sheet method, it's roughly around 6 kg or 6 to 7 kg per square feet. When you go to the steel structure building, your steel requirement is touches
Almost
close
double,
to
more
around
than double,
13
yeah.
or 14 kg per square.
Yeah, that's
So
right.
what I'm trying to say, your cost, which has escalated 60% in 2 years, and look at a data center, it's not limited to that. Only the steel which is placed in the steel structure largely and per huge. So cost escalation of a 60% in steel, and your structure is steel, it comes at a very heavy price than the normal steel which you use in the building. So overall cost escalation which we have seen in last 2 or 3 years, which is a 60%, and vis-a-vis the overall project cost when you extrapolate. Why? Because everything is steel in your data center in the form of racks. Mr. Ethan has talked about, in the form of your transformers, your panel. Right. Of course, there are commodities which actually had increased our cost escalation. I mean, beyond our thoughts. So this will definitely push back us to think about taking a steel. However, I can definitely say is if and over and above there are very few players to talk on who can probably work on a steel structure. So I think these are the large benefits. We can separately discuss on who all players are there in this segment.
No, certainly. Hariam Gora had given a nice comparative, but you gave a slightly different dimension to it.
Shall I one question to the Mr. Kamlesh?
Yeah, sure. Go ahead.
Mr. Kamlesh, just tell me why we are going for the G+5 or G+6 story data center, not more than that.
See, first of all, you need to look at that, it's
your voice is not audible. Can you hello?
Comes from security at the height of a yeah. I'm sorry. Am I audible?
Yeah, now.
Kamlesh, you can put off your video if you want.
Okay, sure, please.
Yeah.
Thank you so much. Yeah. So, Mr. Hariom, thank you so much. Mr. Hariom, see, what generally you think, when you are actually setting up a commercial building versus data center building, what generally height you consider for a data center? So largely you see data centers are built with, the floor to flight starting, I would say from 6 meters. Some actually tries to go 6.5, 7 and 8 meters in today. There are some hyperscalers talking about a 9 meters. So when you actually going with this higher, higher height of the building, when you go with a G+5 model, so obviously your height goes very, it touches around 50 or 60 meters, depending on the height which you see. Second point is, in a colo environment, let's say you have one customers who's into the second floor or a third floor or a fourth floor. So what they look at a threat is, tomorrow something goes wrong in one of the data hall, which is maybe hosted in second floor. Let's say the power got off because of certain reason, because of the issue. I mean, there are some incidents happened in the past. Some location the fire has occurred. Why? Because as the power is off on your particular data hall or for some reason, or I just don't want to articulate that, your temperature in the data center goes very high in no period of 10 to 15 or 20 minutes. You have a UPS backup for sure, but your cooling backup is limited to the capacity which is there in the pipe or thermal storage which you have created. So this can actually create a fire within no time. Okay, so what the threat, if you go multi-story building, so that become a threat for someone who's actually hosted at a second or third floor and for a higher floor guy. So this is one of the reason. And second thing is, why we go in a hybrid model here in India, because look at your land cost, and I think Mr. Gupta has already talked about in the beginning that there are defined corridors of data center where you have a good amount of the network connectivity is available. I mean, of course, we also look at the cost of land, though it is not so significant in terms of overall project value. But of course, it may impact. For example, there are some hyperscalers who have taken land in Hyderabad, which very throwaway price. But these are largely in captive. But when you are looking for colo, where you wanted to nearby within your customers, where the networks are actually largely available, so obviously these factors comes in mind.
Yeah, I would like to shift to Sanjay now. Sanjay, have you done any steel data centers?
Yes.
Okay,
Basically, that steel structure we are using for the chiller platforms, BG platforms, and
no floors of the data center.
For the floor of the data center, that strengthening of we did for the NM1 building that Mr. Dhruv is presented.
Oh, same. Okay.
Same building we converted from commercial building to the data center building.
Right.
By adding some steel structure below that.
Yeah. So in that, I wanted to ask you about this fire business, and it appears to be a very fire is a major issue, because in a multi-story building, a fire at lower floor can affect upper 2-3 floors also. And do you think this can become a major major obstacle in using steel structures for data centers?
Basically, this was a major obstacle for the steel industry. But now we have Intumescent paint, we have calcium silicate jacketing, and sometimes we are using this vermiculated concreting on that steel structure that will prevent steel structure from the fire, and easily we can get 2-hour fire rating. But obviously that will add in our cost.
Yeah, but is 2-hour fire rating, see, when we talk of 2-hour fire rating, 1-hour fire rating, it is generally in relation to human safety. I mean, people should be able to move out. The fire brigade takes so much time to reach. But here we are talking of static equipment which is stored there, which cannot be moved out in 2 hours. It's the data equipment, data storage equipment. So then how do we look at these multi-story and especially steel data centers?
Actually, this providing this fire rating.
Yeah.
So we have multi-story building, 6-story building. Fire happen on the first floor. Right. So steel structure is tend to expand that column size, and that may be try to shift and collapse.
Yeah.
If we protected these all the columns, slabs with the fire rated material, so we can prevent major damages in the building where we have our clients on upper floors or lower floors. So that is the purpose, to provide fire rating to the structure, not to their equipment.
Oh, so so this is where we have to make the distinction. And probably I'm not expert in data centers as such, but probably that is why data are duplicated in duplicated or triplicated in different places. Is what I feel. Correct? Is that correct?
Yes.
So I think that has been addressed by duplicating the establishment. So far we have been following that. But if we can address this issue of fire spreading, but containing within that one particular, captive in that particular floor, that will be a great. Somebody should do some research on that.
Yeah, that fire containment we are always doing room wise or floor wise.
Right.
To prevent the fire to spread and collateral damage in the structure. So that main purpose to provide that fire rated paint or some treatment on the structure to avoid structural damages, and penetration of fire should not go to upper and lower floor. That we are also doing. Apart from this, Mr. Gera has mentioned that obviously that steel price is higher.
Yeah.
When we are going for the steel structure, but we will reduce that execution time around 30%.
That is true.
And there is always cost when we are retiring that data center building. So we will get some money back. Third point, if we reduce that 3-month or 4-month time to make a building, data center building, our billing to our client will start. We should also factor that.
Yeah, that's correct.
If we compare these all the things, so price will not seems a matter. To be very frank.
Yeah, that's right. No, so this is certainly the advantage of using steel, not only in data centers, but in all commercial buildings and all that. We consultant always put this equation in front of the client and use option, you know.
Yeah.
Questions as, but I will move to have experienced some issues or benefits, both. I mean, whether there are problems or benefits in installation of services in structural steel data center building, because data center buildings have a lot of services running here and there, data cables, electrical cables, pipelines, and whatnot. So, Tarun, can you tell me whether steel is conducive to installation of services or not?
Okay, thank you, David G. But I must admit that I'm not the expert on this, but I can express my opinion with the experience that the projects that we are delivering to data centers around the world, that it is not the issue, not at all, from the experience. But I'm not the expert to put the rationale. But if I can go back to your previous question, talking about the fire, right? So now here there are two things. Within the fire protection, there is an active fire protection, there is a passive fire protection. You asked about fire protection to steel, you also asked about fire protection to data equipment. Now, along with this fire-rated material, which protect the steel integrity through passive fire protection, there is also fire methods that we are taking, like fire stoppage, contamination, Mr. Sanjay has mentioned. There are other active fire protection like sprinkler systems and all. Those are there in the place to address the data equipment protection. So passive fire protection plus active fire protection brings the requirement fulfilled to make sure that steel is the best choice. There is no limitation at all.
Very good, very good.
Yeah, just a comment from my side.
So that's an assurance. That's the assurance, that's an assurance for very nice, very nice.
Gris, apart from this, one point normally people are missing, that for the data center or network industry, there is a threat that's called EMF bomb. And steel structure will automatically create a Faraday's cage for all the data protection.
Oh, this is the question I asked actually.
Okay.
So you are saying that it will be actually beneficial rather than being producing adverse effects. Oh, right. Okay, that's great. So I think Kamlesh ji talked about dust problem. You are talking about Faraday's network, and the fire is addressed. So many things are being tackled already, and that gives that gives us a lot of points to promote steel in data centers, definitely. But there are certain issues. I still want to come back to that installation of services. Although Tarun said it's okay. Hiten, do you have any experience of problems in installation of services in steel?
Yeah, basically, Ravid, see, the services are normally put below the false floor, or they are suspended on top. Now, the best way to suspend on top, I would prefer a steel building where I have the eye sections where I can, bolt and create nuts or whatever, and becomes very flexible for me without doing too much intrusion with the slab, because the bottom steel and all is there. So we don't want to get involved in that. Sometimes
even at a later stage,
at any level, at any stage, even in the life cycle of the building, where you want to add a service here, add a service there, because nowadays there's no more false floors. We are doing it on the floor also. So there are different permutations. So what happens is that slowly, if there are no false floors, the ideal way is to take it from top. So you can take it from top and wherever you want, and it becomes easier because you can create some system on top with the bolting or holes, or pre-hold or pre-angled with bolts. I mean the holes. So you can go without, because once the data center is commissioned, it becomes a red zone. So you cannot play around over there and do like Kamlesh was talking about dust. So it has to be given a very, like a Mikhailo said, downtime also should be very small. It becomes a very security.
That's right.
I have been in the, it takes nearly 2 hours to get into the red zone. With the type of, we have to wear the shoes and this and that. It goes on and on. So we have been through hell.
I know. So, but Scott may be having some comparative experience in installation of services in RCC or PT buildings and steel buildings.
Yeah, no, sure. I just think in our experience, when we've looked at or been involved in services, one thing which is good with steel is, and we've seen it been involved within the floor, is rather than the use of standard steel sections, bespoke plate girders are used, and they are used in design. So you can have holes in the webs, so you can pass services through. So they still retain within the floor, but it gives the access to services through if needed as well.
That's right. Perfect. You talked about holes and all that. But Hariom, this heavy loading in data centers definitely, and you are talking of 11-meter span. Sometimes I have designed a data center which has 16-meter span, and the steel sections, the plate girders and all that, they become quite heavy. And so, Hariom, how did you handle all this in your project? I mean, was there any cost impact, time impact in fabricating these girders, the procurement of thick plates? What was your experience?
First, I want to give the answer of the MEP also.
Oh, great.
Yes. Because you are already saying that this is the depth of the beam is coming higher. If the 16-meter span is there, so my 650, 750 beams are there. Okay, then the 650, 750 beams are there. So you can cables and the firefighting, you can take into a beam only.
Right.
Okay, and this HVAC is below the beam.
Right.
And put design the duct like that. Duct is running through in the corridor also. Then your duct is running through the corridor, then you will reduce the height of the building, the floor height of the building also, because your services go into a beam side. So you can reduce the approximately 300, 400 floor height for the every floor, and then you can save the money. Okay. First thing, this is services based. Second is this type. I have also designed the data center for the 16-meter span, 8 by 16 meter. Okay, 8 by 16 meter. My beam depth is coming only 650 because I am putting the beam 333 meters. Okay, and the 3-meter beams is with the heavy load of the 2 ton. This is coming only with the composite design. When you are designing the composite system for the 2 ton, so your decks over the deck slab, the slab is also higher. Your compression force is also higher. So you can handle with the 650 to 750 beam. Okay. Nowadays the UV section is a 610 or 700 is really available. We are using the most of the project. So we are choosing now the roll section because the roll section is nowadays the cheaper than the plated section. And the fabrication cost of the roll section is also cheaper. So overall cost, like Mr. Kamlesh told, this increased by 20 rupees, 65 or 70. When you are talking the overall cost, so overall cost impact is very, very less. Not like a 20 rupees per ton per kg. Sorry. Okay. When you are talking about this is you can take the advantage of the roll section. This is the cost is down by 5 to 8 rupees. And again, your roll section fabrication cost, this is also 5-6 rupees cheaper. So overall cost of the steel is increased by 5 to 6 rupees only, not more than that. So this is I am already told this is the cost. When I have designed this, I have given the comparison of the 8-meter by 16-meter gate with the RCC as well as steel. The cost is approximately same, not much more difference.
Okay.
Because one cost is, I think, coming is 1950, some cost is coming 2000, not big difference. But my time will same.
Certainly is. Correct.
So time is very important. Maybe Mr. Kamlesh told ki they are using the RCC building also a deck sheet. This is a good idea because they are generally at the site they are using the conventional formwork at there. When you are choosing the conventional formwork, this is the hell of the RCC building. This is a 6 to 7 month building is the constructed into a 12-13 month building.
That's right. That's right. Yeah. So I think that was quite nice. I have to come back to Kamlesh ji and Sanjay ji both, because they are doing projects. Data center projects are so fast tracked. And of course, I'm sure Hiten and Hariom will want to talk about it because they are the sufferers, what I'm talking about. See, data center projects are so fast track and the designs are not in place when actually the client decides on the plot and decides on to start the project. So many designs of different disciplines, they go on parallelly. And data center building being like a, it's like a tailor-made building. It is a specific purpose is there to design and construct this building. It's very boutique thing, So Kamlesh ji, and then I'll come to Sanjay ji also. If you have managed such projects, did you find any problems in coordinating consultants' activities? And where there are fights, because I have experienced such fights, but I want to know others' experiences as well in getting the drawings on time, and then there were problems, coordination issues, and all that. And especially in steel, why I'm asking this question is, I'm okay with all these fights and non-coordination and all that, but particularly in steel, where you have to pay the construction material upfront before procuring itself. Here have to entire money and then he delivers. So in this case, Kamlesh ji, how do you handle these situations when you have to first procure, your structural design has to be completed, go for procurement, and still the designs are on drawing board? Kamlesh.
Sure. Thank you so much. I think because of the network glitch, I'll just switch off my video to get the answer. Is it clearly audible to you, gentlemen?
Yes.
I'll just keep running. I'll just keep running my video. So, see, I think from a data center, player perspective, it's good to have a steel construction building because there are many advantages versus you're the RCC structure building. Largely, what I can see is today there are very few players available who can develop this kind of building infrastructure. Maybe I can say L&T, Shopoji, these of the world who actually implement these kind of buildings altogether. And over and above, see, as a core shell, if I see, you have a separate manufacturer who will help you out to generate produce the steel based on your requirement, and there is a separate guy who is an implementer which will help you not just limited to the core and shell. He will also do the implementation of the block work, interior work, creating the rest part of the shell also. So you rightly pointed out, it's very difficult to do the coordination, and then many times when the fight happens, you really foresee that is really the timeline is justified when we say the construction timeline just go half, or maybe it's almost 60 or 70% of your timeline which you do for the RCC and constant method. Yes, it really comes in a question. Maybe what I can probably foresee tomorrow as a customer, if someone come forward who has they have expertise in they do have a tie-up. I'm just again, coming. They do have a tie-up with some, developer who can, create an entire building along with the, core and shell in toto for us, including interior also. So probably this, this JV will definitely, help us to, create a building in a faster manner, and over the periods, if there are multiple players, being available in the market, I think I can foresee also you will all have a competitive rates, on a per square foot basis also. I think these are my, my points which I can, which I can touch upon.
Right. Sanjay. So, have you experienced any such problems while design is going on and we are hungry for drawings and they are not coming in because the timelines are short?
Actually, especially in my case, I never faced such kind of problems because we have almost all the in-house team. Sales sir is almost part of our team. So our structural design consultant is Etin sir and Sales sir. We have NK Jain sir. They are all working in a coordinated way. And before they start the job, they will give the drawings. And improvisation also, they all sit together and try to resolve all the issues without having much changes in the design. A recent example, we are doing chiller platform with the structural steel. And I have a pressure of the timelines. I have hardly 10 days to erect almost to 400 to 500 ton chiller platform in a steel structure. Our team is nicely designed that with a nut bolt system, everything was fabricated outside. When terrace slab was casted, we place everything on terrace and tighten the nut bolts. Even our design team is provided support structure for pipes, and everything was well coordinated. So I am not facing such issues in my case, but Kamlesh is rightly mentioned, when we have one consultant in different country and other consultant in different part of the world, so coordination may be an issue, because when we are going to this kind of structure, so proper coordination is required. We cannot do any changes in later stage.
Maybe I can also add it. I can also add it here, and this comes with a pinch of salt.
Yeah.
Why? Because see, look at the cost escalation which has happened in the last two. I think I just talked about that. Obviously, and the difference which I already talked on, that when you go with a steel structure building, again there are definitely high benefits. So when you are doing a speculative design, so again, and coming with that, when you are doing a speculative design, obviously you may not have a certain pressure on the timeline. But when you are working on a pre-commit model, pre-commit means something you are ready to deliver customer with a given timeline. Maybe you can definitely choose this option, which definitely goes viable in terms of using a steel structure building. But when you are working on a speculative model and seeing this the shift which has happened in the recent 2-3 years, huge rise in the cost will really put us on a back foot. So I think as we move on, what my expectation would be, rather in general, if the steel cost being controlled nicely, where when we do generally take care of the inflation which we foresee, a normal inflation which occurred, but a shift from X price to the price something which is a X plus 60%, that's become difficult to justify in the system, and that too on a speculative. So I'm coming with a speculative design. I'm not getting into the pre-commit. Of course, when you go on a pre-commit model, what actually help you out at the revenue realization, it happened very fast. So your revenue realization vis-a-vis your the cost which you added to your infrastructure to develop a DC will be much lesser. So I think your revenue realization will be more fruitful by choosing with the steel structure building.
Yeah, okay. Let me come to a very see from all this discussion and from all the presentations that in the morning. In fact, Sunil Gupta told us that there will be hundreds of data centers in tier 2 cities, which may be small in size, 10,000 square feet or something. Is already indicated. But do we have sufficient, adequate number of players who can design and build? Design is fine. Design, we can tackle large number of projects together. But if talking of second tier cities, Indore and Bhopal and Amravati and Buldana, so where you have to start erecting these structures, do we have trained contractors in steel structure building, fabrication and erection throughout the country? And that is a challenge because we cannot miss this opportunity. There are so many data centers coming in. As the data center professionals as well as steel promoters, we cannot miss this opportunity. So what needs to be done? I'll start with Tarun because he is in business development and he may be facing similar situations where skilled workers, skilled contractors are available. So Tarun, what is your take?
Okay, Girishi, again, I must admit that I work on things that serves the data centers on the steel, that is coating to protect from a fire. But in a general perspective, right. I see that
but that is why I came to you. You are in coating business, right?
Yeah.
So that means you need steel data centers, but do we have adequate infrastructure to build so many data centers? I mean, you have clients who are contractors. So do you see any presence of such contractors in India? That is what I'm asking.
Yeah. So I see that our capabilities and adequate resources are growing at phase how the demand is facing. So there is no doubt about it. In terms of skilled contractors, the fabricators and the erectors are going at a rapid speed. We see that everybody is adopting to new technologies in terms of designing, optimizing the things to deliver the requirements faster. That is also happening at a rapid speed. So I see that things are happening at a required pace. And secondly, coming to installation at a low 2-tier cities, we see that the supply capabilities or the deliverable capabilities is also growing at much faster. Today, we have a lot of erection companies or other service companies who are able to deliver at any remote kind of a location. Whether it could be material that need to be used, whether it is a service that need to be done to construct the project at a remote location, things are very much available. This is my comment.
Okay. So, Hiten, what do you think? Do we have such people with us who can fulfill our requirement?
Girish, we have been noticing for years, initially we didn't have too many people. And slowly, as you are getting the demand, the number of contractors are going more and more. The players are more in the market. So I'm sure, as you said, as Sunil said, in the morning that there is going to be a tremendous demand because of the need of the hour is having data centers, because we are all going into the digitization. Because of the digitization, these buildings are required. Now the contractors who are PEB contractors who used to work on all the factories and huge sheds, I'm sure they will also start adapting. We've got Damir and Kirby and it will go on and on. We've got, as it is, quite a handful of contractors already working on heavy data centers. But I'm sure they will grow because the demand is required and we need to do it. So, and once the business is there, I think adaptability will be there. And as we have seen also, 7-8 years back, how many contractors were there? Now, how many are there?
True,
so that projection will come. I'm quite confident because the business is there. And you were talking about the next thing about the design part, the challenge of all the combinations taking place. See, we have one issue that every data center has a basement. Okay. So that is a relief. So what happens is that when you start with the basement, and the foundations, and then you can adapt. And actually, if you take steel buildings, and if there is something which has to be added, you can always add a plate here or a plate there to modify the design. And if the demand is changed or something like that. So I feel steel will be better to adapt to all these modifications.
Better to adapt.
Yeah.
Great. So, gentlemen, I try to, instigate you in saying something negative about steel in all my questions, but you have, topped it with all positive points. And I'm sure people who are listening to this will be encouraged to go for steel in their data center projects. So great, people. I have to stop now because we are at the end of our period. But I want to thank Scott, Hiten, Hariom, Kamlesh, and Sanjay and Tarun for this wonderful session. And if I wish, we can, because this discussion can go on and on over over a lunch or a dinner. We can meet sometime and continue doing this. But yeah. But I have to stop now. So, we'll take time later. Great. Thank you.
Thank you, Girish. Thank you.
Thank you.
Thank you so much. Thank you all.
Thanks a lot, everyone. It was a great discussion. Thank you.
Thank you, everyone.
Thank you to connecting with you, gentlemen. Thanks.
I would like to thank all the speakers, the moderator, for such a wonderful session and such an interactive panel discussion. There are a few questions in the chat box. We would send that across to the speakers, and speakers would, once we get the answers, we'll surely send that across to you. For any more feedback, anything, please do write to carol@mxbm.in. Thank you so much. Have a great day.
Sure. Thank you so much, Carol.
Thanks,
for your
everyone.
coordination.
Thank you, Carol.
Good day.
Thank you.
Yeah.
Good day.
Thank you, gentlemen.
Everyone.
Thank you.
Thank you.
Okay.
So, Carol, shall we stop now?
Yes, sir.
I'll propose a word of thanks now.
Sure.
Yeah. So since morning, we have been witnessing a great deal of debate and discussion and very good presentations, very well spelled out opinions and thoughts. I want to thank Sunil Gupta, Mr. Prasad, Kamlesh, Hariom Gera, Scott, Dhruv, and then Hiten, and Tarun Kumar, Sanjay, for their participation in this day's seminar, which is data center and sustainable energy efficient design with steel. So that was great. And I particularly want to thank our main partners, Hempel, for assisting us in enabling us in holding this seminar for all interested people. Thank you all. Thank you. And thanks to our team, Sapna, Andrea, and Manisha, Ranjita, and Carol. Thanks to all.
Thank you so much, sir, for the wonderful thank you so much. Have